Imagine a world without wheels. Imagine how difficult it would be for you to go to school or work every day if there were no wheels. In fact, the wheel is considered to be one of the greatest inventions of mankind. This is because it has revolutionized the lifestyle of human beings. So, what makes a wheel so special? Well, it is this round shape of the wheel which makes it so special. And this round shape is called a circle. So let's see what exactly a circle is and also why is it important for wheels to be circular. Before that, can you tell me a circle which you see every day? In fact, several times a day? Think about it. Well, the circle I'm talking here is the circle which the second hand of your clock or your watch makes. So if you carefully observe the movement of the second hand of a clock, you'll see that the path formed by the movement of this second hand is a circle. So this second hand, it starts from here, say 12, it rotates and comes back to its initial position. And in doing so, the path formed by the movement of the second hand, if you observe carefully, you will notice that the path formed by the movement of the second hand is a circle. Now notice a few things. This is the second hand. It is fixed. The one end of the second hand is fixed at a point. Let's call this point O. So one end of the second hand is fixed while the other end is free to rotate and move about. So one end is fixed at a point O and the other end is free. So this is a fixed point O. Also, the length of the second hand is fixed. Let's call this length L. So the length of the second hand is fixed. Now when it rotates, if I consider this point, so this point is at a distance L from point O. If I consider a point here, this point is at a distance L from point O. If I consider a point here, even this point is at a distance of L from point O because the length of the second hand is fixed L and this point is also fixed, that is O. So what I get is the collection of all the points which are at a fixed distance L from this fixed point O. So we have a collection of all the points. This is a collection of all the points. All these points are at a fixed distance L from this fixed point O. So we can say that a circle is a collection of all the points which are at a fixed distance from a fixed point. So we get a circle which is a collection of all the points which are at a fixed distance from a fixed point. This fixed distance is called the radius and the fixed point is called the center of the circle. So the fixed distance is the radius and the fixed point is called the center of the circle. So if we consider this circle, this fixed point, that is C, is the center of the circle, and this fixed distance, that is R, is called the radius of the circle. And all the points on this circle, whether I take this point, this point, this point, all the points on this circle are at a distance R from point C. This point is at a distance R from point C. Even this point is at a distance of R from point C. So you take any point in the circle, the distance of that point from the center of the circle is R. So this is how we define a circle. We can see circles all around us, from the early morning sun to the alarm clock which wakes you up in the morning. The pizza you have, the wheels of the vehicles you take to work or school, all are circular. So you can observe circles all around you. Now coming back to our question, why are wheels circular? Can you answer this question now? Well, before we go into this, let us see what would have happened if they were not circular. So let us consider that we have this cart and it has a square wheel. So we have this cart here attached to the square wheel. The cart is fixed to the wheel at its center. So the cart is fixed to the center of the square. As the square rotates, the cart moves forward. So let's see what happens. So we see that as the wheel rotates, the cart moves forward, but it moves up and down, and we get a bumpy ride. So as the cart with the square wheel moves forward, we get a bumpy ride. And why do we get a bumpy ride? Let's see. Now, when the position of the square wheel is like this, the distance of the cart from the ground, that is this distance, is equal to half of the diagonal of the square. So this distance is equal to half the diagonal. But when the wheel rotates, the position of the wheel becomes flat, then this is the distance of the cart from the ground. And this distance is equal to half of the side of the square. So this distance is half of the side of the square. We know that for a square, the length of the side is not equal to the length of the diagonal. So this distance is not equal to this distance. So the distance of the cart from the ground keeps on changing as the wheel rotates. So as the wheel rotates, the cart moves up and down, because the distance of the cart from the ground changes, and we get a bumpy ride. Similar is the case when we have a triangular wheel. So even in the case of a triangle, the distance from the center is not fixed. So the cart moves up and down as the triangle rotates. So we get a bumpy ride even in the case of a triangular wheel. In fact, circle is the only geometrical shape in which the distance from the center is fixed. So the distance of the cart from the ground remains the same and we get a smooth ride. And that is why we have circular wheels, to ensure a smooth ride, because the distance of all the points on a circle from the center is fixed. So the distance of the vehicle from the ground remains fixed and we get a smooth ride. So a circle is the collection of all the points which are at a fixed distance away from a fixed point. The fixed distance is called the radius of the circle and the fixed point is called the center of the circle. And this feature of circle makes it very useful in our daily life.